Learning to write code is actually the easy part. The barrier that stops most people before they write a single line is just trying to get the software set up correctly. We are going to clear that hurdle right now. We will download the installation files, configure an isolated workspace, write some initial code, and execute your first script. To follow along, you only need 3 things: a computer, an internet connection, and a basic text editor. Once you finish these steps, your local machine will have the exact same capabilities used to build professional software applications worldwide. Step 1. Head over to the official Python website and download the latest stable release for your operating system, whether that is Windows, macOS, or Linux. If you are on a Windows machine, pause when you open the installer. Look at the bottom of the window for this exact box: Add Python to Path. You must check this box. Checking that box tells your operating system where Python lives. It ensures that whenever you type a Python command into your terminal, your computer knows how to read it. Once the installation finishes, open up your computer's native terminal, or command prompt if you are on Windows. We need to verify that the computer recognizes the software. If you are on a Mac or Linux, type Python 3 space dash dash version. If you're on Windows, just type Python space dash dash version and hit Enter. You should see the word Python followed by a version number like 3.14.6 printed right there on the screen. Confirming this version number right now guarantees the installation worked. It prevents you from spending hours troubleshooting phantom errors later, knowing the foundation is solid. Step 2. Create a new folder on your computer for your code and use the cd command in your terminal to navigate inside that project directory. Before we write any scripts, we need to set up a virtual environment. This diagram shows how the environment operates. Instead of installing every future tool directly into your computer's global system, you create a shielded workspace, isolated for this single project. To build this internal file structure, type python-m vnv space .vnv and hit Enter. Now we activate it. On Windows, type .vnv /scripts /activate. On Mac and Linux, type source space .vnv/bin/activate. Look closely at your terminal prompt. You should now see the text .vnv sitting inside parentheses at the very front of the line. That prefix is your proof. It indicates your terminal is operating exclusively inside your isolated workspace, keeping your project protected from any future version conflicts. Step 3. Open up your preferred code editor. Create a new file, and save it inside your project folder as hello.py. Let's test our output capabilities. On the first line, type print, open a set of parentheses, add quotation marks, and type hello world. Below that, we will add a basic for loop to test iterative control flow. Type for I in range 5. Look at this code structure. When you hit Enter after the colon, Python requires you to use spatial indentation, specifically 4 spaces, for the next line. This physical alignment dictates exactly where the loop block begins and ends. Inside that indented block, type print I. Save the file. Step 4, return to your terminal and make sure you are still located inside your project directory. Now we feed the file to the interpreter. Type python space hello.py and hit Enter. Your terminal should immediately print hello world, followed sequentially by the numbers 0 through 4, each on a separate line. Seeing that chronological output sequence acts as your final diagnostic. It proves that your text editor, your isolated environment, and your system's interpreter are perfectly linked. You now have a cleanly configured, fully functioning Python workspace. As you move beyond basic setup, bookmarking trusted reference materials will turbocharge your learning. Sites like RealPython offer excellent tutorials and cheat sheets for exactly this purpose. Your immediate next steps are to explore more control flow tools, like while loops and match statements, and to learn the PEP 8 styling rules so your code stays clean and readable. No matter how complex your scripts become, this environment you just built is the exact identical foundation utilized by professional software engineers worldwide.